Okay, we're going to be talking about troubleshooting and specifically a dirty condenser. Now, dirty condenser doesn't necessarily mean dirty coils. The same symptoms would apply to anything that affects the condenser airflow. Something wrong with the fan motor, dirty coils, recirculated air from other units. Lots of things can give you these same simulations. I'm going to try to simulate a dirty condenser for you so you can see what it shows up on the gauges and the thermometers and things like that. So we've got our system here, it's ready to go. It's a 410 system. I'm going to turn it on. After we do the simulation, I'm going to bring out a troubleshooting card and we're going to look at that. So let's start by getting all of our electronics hooked up. We're going to be taking an amp reading because amperage is affected by a dirty condenser. So we're going to get that up here on the common line to the compressor. We're going to get our electronic gauges going. We've got them hooked up to where we can monitor superheat and subcooling. And we're going to be monitoring the split across the indoor coil. So this would basically be the air going into your home. So we're ready to go. Everything's hooked up. I'm going to turn it on. So you hear the condenser running. The indoor fan is running. We're not doing anything to the airflow just yet. We're going to just run normally for a second and kind of stabilize. Compressor's drawing basically 3.5 amps. It's rated for 8 or 9, so it's lower than necessary. The head pressure is 240, and the suction pressure is 141. You know, nice and low. We're starting to get some cooling out of our evaporator coil. We'll let that stabilize. Our liquid line temperature feels fine. It shows it on here being about 80 degrees. That's fine. But we just started it. We got to give it a second. You know, technically we need to give it 10 or 15 minutes. We're not going to wait that long, but that's how long you would normally have to wait. Our amperage is still good, 3.5 roughly amps. Now we're starting to see some cooling going into our house. 59 degrees supply air. And our head pressure is stabilizing about 243. We have some subcooling going on, and we have some superheat going on. Everything's working pretty good right now. Now we'll go into the condenser, dirty condenser situation. I'm going to start by turning the fan all the way down. I've added some rheostats just for this purpose. So the fan's as low as it can go electrically. That's not going to be enough, so I'm going to put a block on top and block some more. So I'm probably blocking about 80% of the airflow leaving this condenser. Same thing would happen if the fan wasn't working correctly. There's lots of things that could cause this. We're going to notice right away our head pressure is starting to climb. It's getting up into 320 range. You probably won't see anything here just yet, but it's early in this process. Our amperage is almost 5, so our amperage is going up. Our compressor's working harder, right? Because the head pressure's going up. So we'll let this continue to climb a minute. Now it's 350, almost 360. My liquid line's starting to feel warm and it's starting to show it. 96 degrees and going up. It's actually getting quite warm. Now when our liquid line temperature goes up, we lose efficiency. Because now we're feeding our meter device with really warm liquid and that's just not good. We're also going to be not rejecting heat out of this condenser because we're not moving air across it. That's not going to help us. So we're 390 on the head. Our amperage is 5.7, so our amperage is going up. We're still getting nice and cool air in the house. Another reason why the homeowner may not notice a dirty condenser. They might get cool air, but this machine's really going to be suffering outside. Now our head pressure is 400, over 400. And our liquid line temperature is 104. It's really starting to warm up. Our amperage is 5.9, almost 6 amps. Compressor's starting to work a little harder. We're just now starting to see the effect on the indoor unit. Now we got a 60 degree, 59.9, 60 degrees on our supply. It's just starting to be affected. 420 PSI on our 410 machine is not high, but it's higher than it needs to be, and we're going to see that. Okay, let's look at our amps. 6.1, still going up. Our head pressure is 426. We'll give it a second. Our liquid line temperature is quite high. If I was in the attic and I grabbed a liquid line like this in the attic and I felt it this warm, I would know I had a problem with my condenser. I would know right away. So 430 on the head, 142 on the low side, and our liquid line temperature continues to rise. 110 now. So our efficiency is going to go down. We're going to start seeing that more and more on the inside unit. Our amperage is now over 6, still going up. We'll let this continue to go. I'm going to turn the fan completely off now. So now we have no condenser fan. And we're going to see a quick rise in pressure. Now it's starting to climb pretty fast. 470. There's no air moving across my condenser coil. It's really going to have a hard time making any liquid. Now we've got 116 degrees on our liquid line temperature, almost too hot to touch. That will translate to an issue on the inside here in a second. Certainly going to cause our amperage to go up. Now we're at 8.2 on our amps, and our head pressure is 580. When it gets to 600, I'm going to turn the fan back on. 125 degree liquid line temperature. We're over 600 degrees. We're almost 62 degrees on our indoor air, so we're starting to affect the indoor air. And we'll go ahead and shut this down, and then we'll talk about the chart. All right, let me pull the disconnect and we'll get the fan off and be a little quieter. Okay. So I have a troubleshooting chart right here that I want to bring out. This is a chart that you would use if you're trying to figure all that out. If you're out in the field and that stuff is going on and you're not sure, what does a dirty condenser do? Well, look at this chart. This just started the compressor. Compressor had high amps. It definitely went up. We saw it on the amp probe. The compressor would have thermaled out. It would have opened its internal bypass. That's two different things. The internal bypass is pressure related. The electrical thermal is temperature related, both of which were going up. As we move into the condenser, not able to turn gas into a liquid. Absolutely. If we're not rejecting heat, we're not going to make a liquid. We're moving through the condenser. We're coming out. It says we're going to have a warm suction or liquid line. And we definitely had a warm liquid line, almost to the point where we couldn't touch it. Possibly bubbles would be occurring in our sight glass because we're not making a liquid. As we get up past our metering device, remember we've got that warm liquid going in our metering device, we're not going to perform well. We saw that right here. Evaporator coil may not get a good supply of liquid, therefore it's not going to perform well. Absolutely. If we're not giving our evaporator coil nice, cool liquid, it's not going to perform well. So it's going to affect our superheat, and then it's going to go back to the compressor, and it's going to continue to affect our outdoor system. Although during this whole process, we had a decent amount of coolant inside the house, that's not a good indicator. So we're going to use these troubleshooting charts, and we're going to keep these units running well by diagnosing them this way.